Okay, just a quick video on quadratics. Lots of questions we could ask about them. Okay, are they, reflected? So is it in the traditional up position or is it reflected down? Vertex, and that's the same as your max or min, because obviously there's either going to be a minimum value or a max. We could find the axis of symmetry, which is the line that it reflects around. X-intercepts, Y-intercepts, when is it increasing, or decreasing, we could ask the graph. Also, we can always ask domain and range, right? So there's tons of questions we can ask about these things. Okay, so I want to talk about completing the square first. I will show you a way to cheat to get the vertex, okay, which is kind of handy. And we can kind of go through all these questions. All right, so first let's complete the square. All right, when you complete the square, you're kind of stuck with this because it's not equal to 0. You can't move things around. We don't have access to both sides because this side has to be the name of the function. So what you can do is you can only manipulate this side. And usually in algebra, we manipulate both sides because we have a teeter-totter, and if we do it to the right, we got to do it to the left. So now we're only doing stuff to the right. So what that means is if I have 8 and I add, say, 2 pounds over here, then I have to subtract 2 pounds because it has to stay balanced. And so if I add 2 to the right, I can't add 2 to both sides because, again, I'm only messing with one side. So whatever I do to the right, I have to undo it on the right to keep it balanced. Okay. So completing the square, we're going to focus on these two, okay? And you don't want there to be a coefficient here, so we're going to factor it out, okay? So I'm going to factor out the 2 and get x squared plus 4. I'm going to kind of leave a little space there, okay? And the idea of this, and I probably should put the x there. The idea of this is that when you square something, if you have x plus 5 squared, and you do the box, you always end up with duplicate things. You get x squared, you get a positive 5x, a positive 5x, and you get 25. So this ends up being 10x. And if you're like, well, how do I go backwards, right? Or how would I get the 25? Well, you would just take the 10 and divide by 2 because there would have been 2 of them to get the 5. And the 5 squared is what gives you the 25. All right. So again, if I have x plus 6 squared, I know when I do the box, I'm going to get 2 sets of 6x. So I'm going to get x squared. I'm going to get 6x and 6x, and then the 36 in the corner. But what if I don't know this, right? Well, here I'm like, okay, so I have a 12x, but I know it's a square, so these had to be duplicates. So divide by 2 is 6. 6 squared is the 36. So we're going to use that idea to do this. So if this is 4, I'm like, oh, if I take 4 and then divide it by 2, I get 2. And then if I turn around and square that, I'm going to get what goes here. So I know a 4 goes here. Now, over here, I have to subtract whatever I did over here. Now, you might be thinking I added 4. No, you did not. So you need to put that 2 because that 2 distributive property, that's really an 8. So over here, I'm going to remind myself, okay, I have the 2 out front and I have the 4 here. So when I distribute, I get an 8. The 2 times the 4, I have to undo that over here. Okay. So at this point, then I'm like, all right, well, then this has to be a perfect square because I forced it. So if you go back, square root is x, square root is 5, it gives you that. Square root is x, square root of 6, it gives you that. Square root of x is that, or x squared is that. Square root of that is 2. It's all positive, so that's a plus. And don't forget the square. That's easy for people to do. It's a quadratic. It has to be squared. Otherwise, where does that come from? And then over here, you have 5 minus 8. So you are at minus 3. And this, okay, is in the form that is going to give you the vertex. So we call that vertex form, okay? All right. Now, this tells you some stuff in that form. This tells you other things. So what is your vertex? Remember the shift? Remember when we talk about that? Like I know whatever causes 0, this guy is shift to -2, shift to -3. I know it's not reflected, and I know it's a little skinnier than it normally would be because of the 2, okay? But I do know the vertex is at a -2, -3. That's my vertex. So I can answer a bunch of questions on the next page. But let me show you how to cheat a little bit on this. There's sometimes when you do conic sections and stuff, you absolutely have to complete the square. But there is kind of a way to cheat. Okay, the vertex formula is the opposite of b over 2a. Okay, and that's worth memorizing. That I do know. I don't memorize a lot. I know that guy. Opposite of b over 2a. Okay, what's the opposite of b? -8. What's 2 times a? 2 times a is 4. That is going to give you your input. See how it gives me my input. Okay, so how do I get my output? Well, again, anytime you want output, you sub in the input to get the output. That's how I mean, it's a machine. You shove the log in, it turns it into logs, you know, or it turns it into planks that you can use on your deck, right? The function is a machine that has a job. Its job is to take this input and spit out an output. You know the formula, you know the function. So if you know the beginning part, the input, because of opposite of b over 2a, you can find the output. So sometimes people will write this as this, and then they'll write f of a negative b over 2a to say, find this, and then shove it into the function, right? Sub it into the function. All right, so let's sub a -2 in to that. And again, don't, mess up here. So probably a good idea, again, when you sub in negatives, always use parentheses. Otherwise, your calculator won't square the -2. All right. If I have a calculator that does order of op, I would just type this puppy in. You're going to get a -3. That's your vertex. And if you're like, well, Julie, how do I write vertex form? Like, well, you know that the shift would be a +2 because it's always the opposite on that. You know it's squared. You know the shift on your y is output here. And then you're like, well, how do I get the coefficient? Well, what's the coefficient here? 2. Guess what? The coefficient here has to be 2. Okay. All right. So we know that. One other thing we probably need to do, let's find our x and y intercepts. Sometimes this form up here is better. All right. So let's see. Let's skip another page here. What do I have? It's 2x squared plus 8x plus 5 equals f of x. Okay, so if you think when you sub in 0 for input, this would be a y-intercept because of your y spot. All right, so let's sub 0 in. So I get 0 plus 5. And so I have a y-intercept of 5 because the number's in the y spot. So that would be my y-intercept. X-intercept is when the number's in the x spot. And sometimes, right, with a parabola, we are kind of expecting 2 of these usually, right? Okay. Obviously, there wouldn't be any if it's reflected down like this, right? But if it's going up, then, we would expect it to cross twice. All right. So this is saying, oh, your output is 0. What is your input? Well, that means you have to factor this or do the quadratic formula. Okay. Now, again, with factoring, I might spend, I don't know, a minute or so. Let's see. If I put 5 here and 1 here, notice I get 11. Okay. Everything's positive here. If I move the 5 and put the 1 here, I get 5 and 2, that's 7. So I am going to go straight to the quadratic formula. So I'm going to pause and get that all done, and then I'm going to come back so we can answer all our questions. Okay, so I did quadratic formula to figure out my x-intercepts because factoring wasn't going well. So opposite of b plus or minus b squared minus 4ac, all of that. Again, I would do a calculator on this. Don't trust yourself. It's easy to screw up. Factor it into things that have square roots if you can. That comes out. When I divide, they all have a 2 in it. So divide by 2, divide by 2, divide by 2, I get this. So these are the exact values. So, you'd have this comma 0 as one x-intercept, this comma 0 as the other one. I went ahead, because I'm going to graph this, I went ahead and typed it into Desmos. See if you can get that in there. Oh, what happened to the second one? Oh, I hit a key while we were moving. Oh. Don't know what happened there. Maybe one more. Oh, come on. All right, so those are my 2 decimal approximations, okay? All right, so what we're going to do then is we are going to answer all of the questions. So we have our y-intercepts, we have our y-intercept, x-intercepts. So let's go back, and I am going to try to graph this thing. All right, so our vertex was at what? -2, -3. And because it is not reflected, it's opening up. So this is going to be a min. And this is our absolute min. It's also a local min because it's in the middle. So it's also a local min. But that is going to be your absolute minimum value. Can't get lower than that. So in story problems, these tend to be like, what is your maximum profit? What is your minimized cost? You know, because you're asking that. Okay, axis symmetry. Okay, so let's graph this guy. -2, 1, 2, 3, -3. All right, so this thing's going to go here, and we found our, what was our y-intercept to go in 5, 1, 2, 3, oh, +5, 1, 2, 3, 4, +5, right there. And then my, let's see, so about a -0.77, I'll put a dot about right there, and then -3, 1, 2, 3, and a little bit past. Okay, so now notice this is symmetric, so this is a perfect point. So here's my axis of symmetry. So if I go 2 over here, I'm up 5. I'm going to go back 2. So from here, this is my 1, 2, and then go 1, 2, 3, 4, 5. So I can reflect that point over. Okay, now make this curvy because it is definitely a parabola. There we go. All right, so now let's see what else. Axis of symmetry. Well, lines that go up and down have the formula x equal, because x is stuck there. X is stuck at a -2, and notice that's the value of the vertex. X is stuck there. X-intercept we had on the other page. Y-intercept was 0, 5. If I have time at the end of the video, I'll rewrite those, but I'm afraid I'll run out of time. All right, when is it increasing and decreasing? Okay, so if I have a, you know, little amusement park ride here, okay, roller coaster, it is decreasing from what? Now remember, we don't care about y values. So where's my vertex? -2, -3. I am not going to talk about the y value at all when I'm talking about decreasing. So from -infinity, all right, so from -infinity on the x values, right, and to -2. And again, I usually don't include it. You have to see what Newton does. They may include it, may not. That is decreasing. Okay, then it starts going uphill, right? So the roller coaster is going up. That's increasing. And again, -2, in my mind, not included because that's where the switch is, up to infinity. And again, I will accept either. You see if they like brackets or if they like that. I don't know. All right, it varies by book. Let's see what else. Increasing, decreasing. Okay, domain and range. Okay, so domain is like you read a book. So every x value is allowed, right? Positives are allowed, zeros allowed, negative. You can sub whatever you want into that thing. So domain is either all reals, or you could do -infinity to infinity. Okay, what is your range? Well, range is the one time you talk about y. So I am going to cross my x off and focus on my y value. Okay, we start low and work our way high. -3 is allowed, right? We can have a -3. That is our first y value, so -3 inclusive. And then off to infinity, our y values keep going up, so positive infinity. Okay, and I have a minute here, so let's see. Let's write those. Let's do the exact values. So what did we get again? We got -4 plus the square root of 6 over 2. And we got a -4 minus the square root of 6 over 2. Okay. So you should be able to do that for every quadratic. Okay. I will complete the square again for one that's not super pretty. So give me a second. I'm going to pause and we'll switch over to that. Okay, here's one that's not pretty. I took those, factored out the 3. Then there's a 1 under here. So in a sense, what I did is multiply the top and the bottom by 3, numerator and denominator. So I could factor that 3 out, okay? Because notice 3 times that would be that. How do I get what I do? Well, take the 7/3, divide it by 2, which in this case would be a half, and then square it. So that's going to be 49/36. And I'm going to do that to both here and here. And it also has to be multiplied by that 3. All right, so then I square it to get that. And then over here, 3 times that, get a common denominator, subtract that part, right? And over here, the square root is 7 and 6, so it all kind of works out nice. If you want to reduce this on a calculator, you can type it into Desmos. And if you hit this key, it will turn it into a simplified fraction for you. So that's what I did there. So I just, again, took half and squared it to get that, subtracted it to fix my problem. Square root of that is 7, square root of that is 6. That's that. Get my common denominator, 36 over 36. Combine these and simplified. And again, that is how I can do that. Now, again, if you want to do the way to kind of cheat, you can do that as well. Let me pause. Okay, so the way to kind of cheat is take the opposite of beat over 2a. That's your input. Go back to the original and just, again, you can use Desmos or a calculator. You don't have to do all these fractions yourself. So just type it in a calculator. The output it's going to give you is this guy. Right? And then to write the function, you can just be like, okay, the shift is the opposite, square it. The shift on the y is exactly what it says. And whatever your coefficient was in the beginning, right, is still the coefficient if it's factored. And so you can kind of go about doing that way. All right, hopefully that helps. We're kind of over time, so hopefully this works.